Anybody recognize this?
What is that? What kind of tissue is that?
I see a lot of space in here, right? A lot of space in here. Maybe space for like white blood cells to patrol this area. What do we think? It doesn't look like these fibers and this matrix is put together so tightly, does it? Mr. Caff, what'd you think?
No, I think there's a lot of space in there. I think
Yeah.
That's the big clue. There's a lot of like different material that we see in there, but it's not really packed together. It's loose.
Oh, yeah. That's a big hint you just gave.
Yeah.
All right, so we're not getting much here, are we?
No, we're not. We got some work to do Wednesday and Thursday.
Yeah. All right, so this is what we're looking at here. This is loose connective tissue. Loose connective tissue. What? It's also known as areolar connective tissue. Or loose. And this is a big giveaway right here. All this open space, right? See all this white? That's open space. So most of our tissues are not put together that loosely. They're more compact and dense. And another giveaway here is I could clearly see these thick collagen fibers. Remember, collagen fibers provide strength. I see them running through. But I also see the thinner elastic fibers running through, right? These are elastic fibers. Elastic fibers aren't really there for strength as much as they are there. They permit the tissue to stretch a little bit, right? That's what elastic fibers are. So I want to draw this specimen. I want to draw this. This is going to be a microscopic observation. And when I see in my lab book something that looks like this, I know that this is where I'm going to record my microscopic observation. All right, so this, again, this observation that we're looking at here, this is loose or areolar connective tissue. And we're going to be looking at this at a magnification of 400x with a field diameter of 450 micrometers. And now that's the field diameter always for this lens, right? That's always it. We established that. That's done. So how am I going to draw this? In that page over there? How am I going to do that? How am I going to draw this over there? Well, the first thing I want to do is maybe see if I could draw these thick collagen fibers. So I'm going to take a mental image of this, and I'm going to see, like, I could definitely draw some going across the top. You know, 1 here, 2 here. And then I could do a big X here. Looks like 3 or 4 and an X. So, and then a couple on the bottom. And then I have some thinner ones going in different directions. It doesn't have to be perfect. I'm just going to try and draw, you know, somewhat as it appears here. So I'm going to make a thick font size. I'm going to choose the pink color. I'm going to give it some transparency too. And I'm going to start drawing some thick fibers up in this area, like it showed in.
So, how did you know when you do next week as our lab? How did you know which ones were the collagen fibers and which ones were the? How did you know that? That's going to be labeled on the lab, or are we going to have to look back in our notes?
I mean, how did I know?
Well, I know how you know. Well, let's say we give areolar tissue as their.
Yeah, on the specimen that I give, I'll probably have these things labeled.
Yeah.
And for my elastic fibers, you know, I'm gonna do maybe 1, 2, 3, 4, 5, 6 going across, and let's do going down 1, 2, 3, 4, 5, 6, 7, 8, something like that, right? But these are much thinner and they're black. 1, 2, 3, maybe a little thicker. 4. Sometimes they crisscross. So I think that looks all right. Does this look like this? Yeah, kind of, right? Now, what I'm going to do with my 2 fibers, since I drew them, I'm going to label them. When I label them, if you notice, there's always on my microscopic observations this section that says parts to be labeled. All right, that will always be there. The easiest way to label your drawings is to use these words along with the line function. See over here it says insert line. If you choose the insert line with a number 2 and a black, now all I have to do is go from the word to the structure. Boom. And I could do more than one. If I want to show 2, I go back to the original word, do it a second time, like that. Easy. Elastic fibers are these ones, right? So I could go from the structure to the word, from the word to the structure. Perfect. And it's clearly labeled. Let's look at fibroblast cells. Fibroblast cells are the cells that are building these fibers. So these are the cells, these black dots that we're going to find actually on the fibers. Most of the cells in this picture appear to be fibroblast cells. If I want to copy this, I'm probably going to use a big font like a 12, maybe a dark purple, and I'm going to give it some transparency, right? Yeah, something like down here. Something like that. Maybe a little darker. We could always go to more colors, right? Get something like really dark like that. Maybe this one, yeah. Yeah, that's a good match, isn't it? These kind of look like that, don't they? I'm going to go with that. I'll give it some transparency. Ooh, this is touchy. And I'm just kind of scattering these wherever. They're usually found on the close to the fibers, right? And then again, when I'm done, I'm going to go to my lines. Black, number 2 is good. And label these as the fibroblast cells. Perfect. A lot of times in loose connective tissue, we would find white blood cells patrolling in the areas, right? White blood cells, if we see them, I could only make one out. It looks like up here, this might be a white blood cell up here. I'm not really sure. But they look different because if you were to draw a white blood cell, the whole cell would be like kind of light. And the inside, there would be a defined nucleus on the inside. that would be darker, right? I don't really see that with these other ones. I kind of see that here up at the top, but this would be like what a larger white blood cell would look like. But you know what? If I don't see it, I'm not gonna draw it. I'm gonna just eliminate that. All right, so with every microscopic observation, I'm going to ask you to measure something. And in this case, I'm asking you to measure the distance between two collagen fibers. So I'm going to pick any two collagen fibers. I'm going to measure the distance. And I'm going to pick these two, one right here. And let's pick this one right here, right next door. And let's measure the distance. We got to measure the distance. I'm going to use another line. So what's the distance from here to here? That's what we're asking, right? If I could hit the select button, and now I can move this line, right? Well, I got to remind myself, what is the field diameter of this field of view, right? So what is the distance going all the way across? Well, we know that already. We know the distance going all the way across is 400. Oh, that's 450 micrometers from here to here. Well, what is the distance from here to here? I'm going to use my select tool so I can move that line. There we go. And I'm going to go 1, 2, 3, 4, 4.5. It looks to me. Wouldn't you agree? I'm going to do my math down here. 450 micrometers divided by 4.5. This comes out to be very easy math, doesn't it? This is going to be 100. So the distance between these two collagen fibers is 100 micrometers. Easy. Now, what this drawing is actually pretty difficult. This is like a higher level drawing. The drawings that I'm going to give you guys are probably going to be a little bit easier, right? So let's say, for example, I just want you to draw a cell, right? So I'll give you a picture of a cell. I'm going to erase this. And let's say you draw the cell. And the cell is about that big. There's a nucleus. Well, obviously, I'm not going to give you the same list of things to label. There's going to be a different list. It's probably going to say something like cell membrane, nucleus, cytoplasm. Again, but you would still use your lines function to label from the words that I give you to those structures like that. I would still ask you to estimate the size of the cell. The size of the cell would be measured. You need to know the magnification. The magnification would be given. The field diameters would be given. And then you would say, all right, well, if the field diameter all the way across is 450 micrometers, what's the size of this cell from here to here, right? And Kevin, I'll estimate, how many of these things do you think you could fit across if you could line them up?
Okay, 1, 2, 3.
I'm going to go with 3 also. So 3 goes into 4 one time.
And all these, this equation, this is all from our previous lesson, all last week when we did microscopic measurements.
So then, yeah, so then the estimated size of this cell from here to here, right, is going to be 450 divided. We estimated that we could fit 1, 2, and probably a third one here, right? So 450 divided by 3, we estimate that this size from here to here is about 150 micrometers. Okay. But what I want you guys to understand is that not only do we draw it, we have to fill in this information. This information is given. We can't forget we have to label these parts. And I like when labeling the parts to use the line function in CAMI. If you're not using CAMI still, you're going to have a very difficult time doing this. And the line function is here under shapes. It's under shapes. And then again, once again, estimating the sizes of whatever I asked for using this method. The first thing you do is put your field diameter down here and tell yourself what's the distance all the way across. And then you calculate your fit number, right? So remember, the estimated size is going to be the field diameter divided by the fit number. And that's how we got 450, which is our field diameter, divided by the fit number, which we estimated. We said we could fit 3 of these across. So we estimate this size of this cell to be 150. All right, but like in our last example, in this example, it would be, these cells are kind of small. It's hard to estimate the size of them because it's hard to calculate a fit number. But it's not so hard to estimate the distance between, let's say, this fiber up here and this fiber down here, right? That's a distance that's easily measured, right? And we did that. Okay, so yeah, so starting next week and moving on, we're going to be doing a lot of microscopic observations, and they're going to look like this. You're going to be given a page like this with a circle and parts to be labeled and magnification. And I'm going to ask you to estimate the sizes of things. So it's very important to know how to do that. And of course, when you're looking at the microscopic observation pictures, it's important to try your best to draw these things to scale, right? To the size that they appear in the picture. And yeah, that's it. So if you have any questions, let me know.